As you have just heard in my video, I came to Canada as a young boy. And it was a very eye-opening experience. Everything was different, the language, the people, even the food. I had to adapt to the challenges and differences in this new world, and it wasn't easy. For my whole life, I learned to bridge two worlds, and that experience has led me to where I am today. Working to bridge the gap between engineering and healthcare, to develop new technology and help medical teams save lives. My name is Jimmy Q. I'm an engineering manager and researcher at TECHNA Institute. My work focuses on technology for image guidance and augmented reality to help transform surgical agility and precision in the operating room. And that's not a small thing, because it's hard to create that kind of change, especially in an environment where medical teams are often dealing with life or death scenarios. So here's how it works. Imagine navigation with GPS in your car, but for the human body. We can take technology like electromagnetic tracking or optical tracking to determine location of different surgical instruments, either through a small electrical current or vision of a sensor that's attached to the tool. But unlike driving in your car or navigating on a flat 2D surface, we have to consider everything in 3D, including critical structures like arteries or nerves that may be in the way. That's the challenge we help to address with our surgeons in the OR. As surgery becomes less invasive, think of laparoscopy, for example, there are new challenges we need to consider. Take, for example, a patient with lung cancer. To accurately diagnose a disease and determine how far it's advanced, we take a bronchoscope or a flexible camera and insert that into the lung. The problem is that airway branches all look very similar, so how can a surgeon steer down the correct path each and every time? Especially as the branches become more narrow and far apart. What about a patient with bone cancer? In order to remove the tumor, the surgeon needs to be aware of the extent of the disease, as well as the planned margin, say 5 millimeters, in order to help maintain structural integrity and reduce the chance of recurrence. That margin could be the difference between a 5% and 50% chance of cancer recurrence. But they don't see this picture. During surgery, they see the tumor on the bone, but not the extent, and often it's hidden by soft tissue. Let's go back to the example of the lung cancer patient. We can take the patient MRI or CT scan to plan out the path that the surgeon should take. With electromagnetic tracking, we can know exactly where the bronchoscope is going and help the surgeon steer the tool along the correct path. We can overlay this path information and direction directly over the bronchoscopic video, or also present a bird's eye view so that the surgeon can contextualize where the bronchoscope is in relation to the entire path or the anatomy of the patient. Augmented reality is bringing the future into the OR. By expanding the field of view directly over the surgical field. Take the example of the bone cancer patient. We can take the MRI and CT scan to create a 3D model and visualize over the top of that model the extent of the disease, the set of cuts the surgeon needs to perform, as well as the surgical margin. We can add an optical sensor to the osteotome, which is like a bone chisel, and give the same type of positioning feedback that we give to aircraft pilots. With mobile and headset technologies, we can now contextualize and combine all this information directly over the operating field. In the videos that you see, we're taking data from optical tracking, along with the CT information and the planning data, and visualizing it in augmented reality over a 3D printed model. And that's being done on an iPad and the Microsoft HoloLens headset. Combining these technologies will help surgeons be more precise than ever. Those are just a few examples of the technologies we're working on right now. But the applications of them are limitless. In the future, we'll be able to help surgeons perform operations together from across the world, remotely. We'll be able to enable voice command technologies and gesture control for touch-free interactions in the OR. and we can use these technologies to help standardize surgical approaches across different skill levels and reduce that skill gap. Just think of the possibilities. So, if I could go back and give little Jimmy some advice, I would tell him not to worry about the challenges ahead. I would tell him to embrace those challenges, to learn from them, and have fun. But most of all, I would help him understand and appreciate that new experiences can open up your world and change the lives of others. Thank you.